Oh, good morning, good morning. So it's been a while, a bit more over a week since session. So first of all, I just need to remember left off. And if I remember correctly, we have a nice tessellation solution in place. And we're in the process of applying the tessellation solution to every aspect of the game that is going to use tessellation in it. I think we're done with the ground. Now we're just adjusting some of the things related to terraforming and weather. Make them use the system. And I think more specifically we were doing terraforming and this marker. So previously we had this spherical marker that's round. Barely see it. It's white stuff. And yeah, so I'm just going to continue there. I think we should be able to properly place it. It's currently being placed center data points, which is good. So this grid here marks. So the grid pretty much divides the environment data pixels. The placement is correct. I get the visualization of it look a little better. I'll try a visual style for it. I want to be able to get the correct information as well. If we affect this element right now, we just have environment. Oh, good morning, Calvino. Hope dad life is true, right? So we're gonna start by placing this accordingly, change the style of it. Right now, I don't know if that's how I keep it, but I have this vision in mind that we pretty much just highlight edges of this grid with this marker. So we know exactly what pixel changes. As for environment, we already have the information display, but it's going to be a bit. Previously, we went through the terrain patch, fetched information. This time around, we're going to go through terrain base, fetch it. Alvino Dad Life is really good, really fun to be honest. It's probably one, if not the. Yeah, the shovel is real nice, I think. Thank you, appreciate it. Okay, so my first question is why. See here that it centers at pixels, but not correct place. I want to take a look at that first all. And I think it's action terraform. Action fraction. Yeah, we also changed this one. So previously it was just an action. I split everything entity in my game can do is controlled by actions. And then we have actions, which are just for actions, you only need one entity. So jump, for instance, is action. Then we have action fraction. The name suggests that's something that's done between entities. And previously we had terraform as just an action, even though it's pretty much interaction, but we have fixed this time around, so now it's an action between the character and the environment. So we fixed that. So in action interaction terraform, have a terraform brush, and we have terraform brush visualize. It's this one that does placed at the correct. Maybe it's even the terraform brush. Don't know. Doing, but this one is definitely. So when we start instantiate the, if the entity that holds this action interaction terraform, because we will probably have some creatures, monsters, terraform as well. I don't know. Pig-like creatures, pigging, stuff like that. This one just checks if the entity that holds this component, that entity, if it is, visualize. What we also do here is that we add listener, toggle terraform brush change. So if this terraform action gets action state ready, yeah, this is a function we only listen to this on playable entities. That's good. Then we start listening all of these. Update terraform radius I. Yo, what's up, Diligence? Yeah, I'm good. Thanks for asking. How about you? You had a great Easter. So it's this one. Have it here, and then we set brush position. We get type resolution, type UV step, type UV offset, and then we truncate it based on this. This is probably where we go. This could possibly be we're doing it. But we also have do this. Brush. No, 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 no. Okay, okay, I get it. When this is visible, we let update do. And what we do here is that we round and offset it here as well. That is, I wonder if it's enough to is this. We don't need to truncate it twice. I'm wondering what my thoughts were behind. Last stream, I pretty much had to run in the middle of things. But like best case scenario, this is. I don't. Terraform brush should definitely be correct. I will. Still in the center of stuff. Change them. Okay. I'm wondering. The idea is that Terraform brush this will Terraform brush ever have correct amount of data to properly set it? Because what I'm thinking this gives these steps. This is between one get brush delta and brush offset. Resolution phase. Then I use it here together with phase. What I'm thinking that we just keep this one as word. Whatever we because if we want to transform this, we want to transform this to a truncated world space position, and we need to get the terrain size world space. And terraform brush, never have to know thing. Terraform brush visualizer on that might. So that back changed. Position. But pretty much what we get here. Terraform. So yeah, I think it's good morning, Harukanen. You had a nice påsk. So as for getting the visualizer in the correct place, good. Terraform brush visualizer, which makes sense. But terrain delta. Get full terrain grid size. Maybe. Something like this. Harukanen was alright, did not have to. I had a nice one. Eat some good food. Nice people. Can't complain, can't complain. What do we have now? We have, I think we have the correct position. But I'm a little bit afraid that we might get. I wonder if it gets screwed up if go further away from the center. I'm wondering if your suppressor is cutting out a bit too much. Yeah, let's take a look at that. Check it. Might very well be the case. Let me just check if we're using it well. Test, test, test. Okay, let's see if this is a little bit better. Yeah, we can go a little bit lower as well. I just don't want to make... I don't want to get too much background noise and stuff like that. Close, open, pack time. We might lower that one a bit as well, maybe. Okay, let's try it like this. I don't think I have changed anything since last stream, but you never know. You never know what settings you change by mistake sometimes. Okay, this is good. Now I just want to make it... I want to make it bigger when we scroll. We're not having that right now. Terraform brush visualizer stays at 0.2. Let's take a look at our terrain brush. Yeah, I haven't been streaming for a little bit over a week, I think, and I had to cut the last stream short as well. This is a little bit of a warm-up stream, I suppose, for this week. Here we go. Action, interaction, terraform. We have terraform brush here. Brush radius 0.1. And no matter what I do here, we don't get a change. We get a change in brush strength. And we can probably change type as well. And we can change texture, but size. So now my question is, don't we update it correct? Or don't we get it as input? Oh, I might actually know what it is. So general input, scalar, this one. Previously we had a processor here, or a modifier of some sort. Not modifier, processor, where we multiplied the value. So I wonder if that's the case, if we just scroll a lot. No. It might be this one actually. Brush radius error margin and brush radius delta change. Delta change being 0. That's not very good. Brush strength delta change 2.1. I don't know what value we want to have here. let's assume that we get 1 from the input system. So let's try brush radius delta change. Where do we set this one? Private field, okay. Let's try this. Delta change, let's begin with 1 and see what we get. Okay, 1 is way too big. Actually, the visuals of this might not be... We definitely want to bring it up a bit. Or we want to avoid this kind of... I don't even know what to call this one. We want to avoid this artifact, black here. But other than that, I think it's pretty good. I'm wondering, I probably also want to do it such that... I wonder how messy this will get. But like, if we take a look at this pixel that is marked here, like I want to visualize that this pixel will change. So I never want to highlight like half a pixel. It's going to be binary. Either this pixel is included or it's not. Yeah. But okay. First of all, 1 is way too big, so we can probably go with 0.1 here as well. .1. Okay, great. So now that is in place. Probably don't want to fade it out this strong as well. So let's take a look. Terraform brush visualizer, what do we have right here? Sphere center. Let's take a look at this. We do it by calculate grid best. That's good. But, I'm still wondering about these back stuff we get here. We want to offset this grid as well, and I think we want to offset it by world UV, bounce center, bounce extent, grid size, 512. Grid line width. This one bothers me. Okay, so it's just a question of four times grid. Oh yeah. I'm not. So we have this visualization problem as well. So the way we render this is we pretty much take, we have a sphere and then we render the grid behind that sphere. But that's not really how we want to see it. We need to test against depth as well. We want the depth between the sphere. So like if we look from this angle, we're rendering the grid way out in the distance here. We probably just want to, we pretty much just want to render the grid within wherever the sphere is intersecting with the ground, I would say. It's probably easier. I think it is. I think we can just take. Yeah, we need to read the scene depth and we need to check. So the depth. I wonder if we want to reconstruct. So from the depth, we want to reconstruct the world position of it. And if the world position is within the sphere, then we render it. Or we could probably just something like that, I think. Depth and reconstruct. Object depth pixel, scene depth pixel. Depth. It's pretty much what we do here. We get the world UV. Distance to sphere. Could we just do it's greater than radius? Okay, not really. Change sphere radius 0.8. Okay, we never do anything with that one. Yo, what's up, Ling Ling? We're just doing a little bit of a nice terrain marker here. Looks all right, although definitely want to avoid this line around. I don't think I want to keep that. That's great. I just want to get rid of, or I want to place it at the correct point as well. So we need to offset. We need to offset world UV, I think. Yeah, we do. And then I wonder this position VS. Yeah, that's the position world space we want to use. But we want to offset this with half grid delta, I reckon. So we have that information. Ling, rounded edges are literally confusing to me. Is it a shaded thing? What rounded edges are we talking about? Okay, I wonder, do I have enough information in here to properly actually, let me just do this real quick. So we want to offset this by half a pixel in our values. Bounce extent 50, grid size 512. Is grid size the entire terrain base? Dimension 100. Patch count 4. $128. Yeah, I think it is. I think we can do this. Plus what do we want to do? We want to do bounce extent. Bounce extent divided by, is this even the extents? Yeah, it is. Okay. So what I think we want to do is bounce extent XZ 2 times this divided by 2 times grid size XZ. So we might as well remove the 2s here, I think. Let's try this. Any round edge or surface. I've always worked with straight ones, presumably round ones are shadow products or shader products. Yeah, I think the go-to solution or to get rounded edges, or the best way to get it, is shader related. But the most popular way is probably just to have rounded edges on images, to be honest. Okay, this is not correct at all. I haven't done much coding over the last 2 weeks. Life's so busy. For real. I can relate. This is pretty much my first session in a little bit over a week. Okay. Bounce, extend, XZ, XZ. Extent is 50, 50. Oh yeah, grid size. Yeah. We want to do grid size X, Y. Grid size in 2 dimensions. Boundary 3. But we don't get half, so let's do 4. Lily, I have my C# internship starting July 1st, so I did cop a C# book. I can read some every night though. Nice. C# internship. Why are we still located? And this jump we get here, definitely need to fix that one. I don't want to visualize. That's going to be hard as well. I don't want to visualize this marker on my character. So I don't know how we're going to do that masking though, but we'll get to it eventually. Grid size. This is probably how I would like it. Roughly. But we want to offset it. We don't want to change the grid size, because then the further away we get from center, the more offset we're going to get. Feeling, hey, look, I love Java. C# is like Java. I'm so happy. That's pretty much the same experience, or like that's what I thought as well. Still think, even though I haven't done anything in Java for a long time. But like the change coming from Java to C# wasn't big at all. So that's nice. Okay, so this positioning here, yeah, we need, okay, I think I know what it is. Yeah, I do. But that's not what I want to fix right now. I want to fix the offset. Which makes me wonder. We're gonna do this. Grid line width. We're gonna do test vector. Then we do, instead of this offset, I'm gonna go with test xy. And then let's just try and adjust it ourselves first. My initial idea was that the offset should be bounds extend times 2, so that's 100. I thought it would be 100 divided by 512 times 0.5. 0.098. But that is not the case. Why does it cut off some edges? It has to do with the positioning of the Terraform brush visualizer. So when its position is truncated to a pixel, and we don't adjust the height. So what ends up happening is, because this marker is basically just a sphere, so what ends up happening is that part of the sphere ends up under the terrain because the Y position of it isn't corrected. And if part of it ends up under the terrain, we don't render that part. And yeah, it's a problem. The rasterizer has something to do with it, but it's not the cause of it. It might be the highlighter of it. So times 2 times 2. That's not entirely correct either, so I'm thinking 100 divided by 59. Oh, yeah, I might know. 512 minus, we have some padding, some overlap. Minus 2, minus 2, minus 2. And I found 6. 0.19. 0.198. 8. 26. 29. 15. 16. Well, 0.21 feels a bit too big. I wonder what do we get this value from? Something like this, I think, looks nice. Lingling, my next 2 coding things are for school and they are no fun. First I read so fun. Verilog and IDP. I have no idea what either of those things are. Zero 0.21 divided by 512. 100 divided by 512. We're roughly there, I think. Okay. So what I think is that we need to remove... I don't know if this is the way I want to do it, but we need to remove the padding we have here. So what is the padding? What is the padding? We have 4. 512 divided by 4, 128. Or actually, the padding is already removed. But 12. Zero point 0.21. 0.1953. 53. 2. 2. Or 0.5. Yo, what's up, Jax? A few days no see. Yeah, I've been busy for the last week. First, I was sick, and then I've been busy with some other stuff. Unfortunately. Lingling, exactly my point. Verilog is a hardware description language. IDP is a logic programming language. Could be fun. This makes no sense to me. So basically, we draw a grid that is grid size. We draw our grid based on grid size. 512. But we also draw it based on world UV grid size. Could we just do 1 divided by 512? Way too small. Now we need to offset it by half a pixel in world space. So we need to get this in world space, and that's what I maybe 50 divided by 512 to 9. 100 divided by 512. This should be the correct. Maybe. 5. Yeah, okay. So if we do this, we get a full pixel. And then we multiply it with 0.5. This one doesn't give the correct either. Why not? 0.2, 0.1, 0.2, 0.2. It's almost correct. That's true. Or actually 0.1958. 0.1953125. Exactly. So we offset one full pixel with these values. So if I just want to offset half a pixel, we should just multiply this with 0.5, right? That seems not to be the case. 0.5, oops. Oh, times 0.25. 0.25. Two, 2, 2. There we go. Okay. So yes, it's 512. Actually, 100. So 512. How does this make sense? 512. This divided by 4. This divided by 8. Hmm. Ling Ling. I got class from 10:30 to. Oh, okay, I feel for you. So, like, things you have to be at, but long as breaks between. Oh, well, sounds like a great study day. Yeah. Try to make something positive about out of it. Force yourself to study in between. Pretty hardcore day. Okay, so what we have here, what we want to do is 512 times 8. Does this make sense? What am I not getting here? Do, 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 do. Fifty divided by 512. Terrain patch. We had 4 times 4 terrain patches. They're 128 big. 1 divided by 5. Ooh. $128 divided by, or actually 512 divided by 100. Okay, I can't make this math make sense to me. 512 data values in each dimension. 100 meters. Each pixel is 2.1953. But okay, I get it. I think. Yeah, we changed this to world UV here. So it's between 0 and 1. One divided by 512 gives us the wrong 0.0. It's this space change here. We could also, yeah, probably. I guess we would like to offset this. Now I want to offset the world UV. I don't want to offset these positions here because we want to use it here as well. But shouldn't it be 1 divided by 512? That's 1 pixel size. 0.00. We get this, but if we multiply this, what is 0.5? Okay, that's way too small. Or actually, yeah, there we go. Okay. So we just need to handle it in UV space instead of world space. So this offset should be, where do we have it? Uh, 1.0 divided by grid size X, Y. We do 2 times here because we want half a pixel. There we have it. What I'm wondering now, we're gonna fix the clipping of the edges as well. This one right here. But I'm wondering about this sphere as well. Talking about this one around the edges here. Why do we get that one? We introduced it with this one. If distance to sphere, sphere radius, saturate. Four times grid. Eventually we want to have color here instead, but let's see here. At the edges, we might have something that is equal to this one, but grid should still return 0 or something close to 0. This 4 times doesn't really do anything after saturate. It's extremely weird, this one. I want to see what kind of result we get by just returning grid here. That circle makes no sense to me. Hmm. Why does grid return 1 here? Grid line width does not affect it. Okay, so this is some artifact of some type. Hmm. Do we screw something? This offset? No, we don't. This position here. Yeah, we might. Do we recreate the wrong world space position is my question. So return .4 position, yes, 1.0. Okay. Mm. Let's do it without the loom. It's hard to see. Think so. Inverse position. World UV might be a better way to test. Better thing to test. Didn't really tell us anything. Hmm. Try post processing bloom. That doesn't get rid of it. Doesn't affect it, doesn't affect it. Offset doesn't affect it. Return 0 here. I don't know. Terraform brush visualizer. Do we have? One doesn't affect it at all. This one we have already. Ooh, actually. 0.01, 2, 3, 4, 5, 6. So 0 actually leaves us without it. Okay. Okay, so this grid method, we've used it on multiple occasions at a lot of different places, but I've never seen this artifact. It's like calculate grid best. It returns 1 at. It returns 1 at edges controlled by this. Distance to sphere. Okay, without this one we don't get anything, but then we also get Yo, what's up, Viral Air? Yeah, I just muted myself for a sec here. I'm dumbfounded. What is... And yo, by the way, I wonder what makes this circle appear. We actually get it around the character as well in this case. Does that make any fucking sense? So if we take this point around the character here, the reconstructed 3D position is outside. Some of it is outside and some of it is inside. If it's outside, we return 0. So that's probably... That's what we get here. But then here we're inside it. But what boggles my mind here is that, yeah, we are inside the sphere here, but this should in no way be marked as a grid line. It is, unless grid 0. This makes no sense. Like, why would this pixel be 1? We don't have this issue at all if we remove this one. We can see here that, yeah, they are not grids. Like, by adding this one, distance to sphere, what makes the black one here becomes white here? We add an early exit. We return black. And that makes this pixel go from black to white. How does that make sense? Or what am I missing? The only thing we add is a check that returns black. Or is it because see what happens if we do one. We have a problem with grid being more than one or less than one. Yeah, it has to do. I want to try inverse slurp 0, 1, 0, 1. And then we add to it, that's true. Better or worse? Pretty much the same. That's good to know. Okay, might it actually be We don't get it here. Okay. I want to wait with this one. Float 4. We don't get anything at all. Wonder about this computing screen position. Compute screen position, transform world to age clip. I'm a little bit worried about calculating the screen position in the vertex shader. Interpolating, maybe. What do we want to do? Not getting anything here. It's weird. But this reconstructed position should be outside as well. Yeah, I'm wondering if the reconstructed world position is wrong. compute world space position, we give it UV. From position in screen space, which we calculate here. Object depth pixel, we don't use this one. Yo, what's up, Cooler SK? Sample scene depth. Yeah, we get the correct depth, I'm pretty sure. This UV might be correct. Scene depth pixel. Real depth. Yeah, we might. Do we get? In this case, right about here. Yeah, we get lines up to about here, that's correct. Do we want to check if I wonder if we want to check if the red depth is less than the depth we get from the object itself. But linear eye depth we should be able to do if scene depth pixel. I always forget depth in view space. If it's bigger than input.position vs.z. Are we going? Are we growing towards the camera or reducing? Let's try it. Okay, so if we do like this, we don't get anything. Do it like this, we get the same. I have no idea. Like, I'm questioning, like, how does this make sense? So with this if check here, we get a white line here. We just remove this one. We don't get anything here. How does that make sense? How does that make sense? Has to be right on like if we return 0 that we render something behind, but I don't think that's the case. Right. The fuck. And if we do okay. Have this. Yeah, there we go. We're gonna have to do like why does having the check here works but not up here? How does that make sense? Oh well. Yeah, okay. And we definitely want all off. If we're inside it, we still want to render it. This one is rough though. This one as well. I don't know how visible it is through stream, but it becomes a little bit lighter here than it is here. It's like we render it twice from the outside, once from the inside. Yes, we render both sides, but we do want to render both sides. So if we're looking at it from the outside, we render the front face, and then we render the back faces. If we're only looking at it from the inside, we're only rendering back sides, and that's why we get less alpha. So what can we do about that? We want it to... I want to do said testing, think, but not like this. Have back front off. Or I guess the best way to do it, or one way to solve it, is that we just return 1 here. But if we do that, we disable the option of having a less than 1 alpha for it eventually. Do Could add the depth test. Yeah, maybe that's a good idea actually. Object depth pixel, scene depth pixel. And then we compare these two. So we could do grid float is within sphere. Float is, do I care in front? Scene. Let's try this first. Turn object depth pixel. If object depth pixel is bigger than scene depth pixel, I think. Yo, what's up, Calvino? Yeah, one could think. One could think. Okay, that's good-ish. And then we do if it's within sphere and is in front. Then we only render it once, no matter where we are. Okay, so that's good. That's fucking beautiful. What I would like to solve as well is like best case scenario, I don't want to render this grid on top of our character. But to be able to exclude the character, we would probably need to do some sort of masking solution. I don't know. So it's not going to be only the character. I mean, probably don't want... So objects, we could mask objects that are outlined. We can do that pretty easily. But that would still leave our environment. So if we have trees or bushes, they're going to get a grid as well. Like, I'm wondering if there's a easy way to do this, a nice and clean way to do it. We could compare to height maps, but if we're going to do that, we need to send down height maps to the marker shader. I don't want to do that because worst case scenario, we might need to send down 8 textures, maybe 4. That's not good. What else? What else? What else? What I'm getting at is we could, or what I was thinking is that we use outlines texture pass, either this one or create scene texture pass outline this one. We can mask this one, so that means that every outlined object doesn't get the grid. But non-outlined objects do, which is going to be most of the environment in the end. Mask texture. Now, I think we're gonna have to go with some form of stencil texture stuff. Yeah, I don't want to do that. You could do. Let's see here, what do we have? We could make it so that we could play around with cues, which is probably the best option actually. Just render this Terraform brush visualizer way earlier in the queue. So for environment, we have a render queue of 2000. Then we render this grid. And then we render things like trees and bushes. So I don't, just by changing this one to 2001, let's solve it. Do we render after? We might want to do skybox, copy depth. What do we draw between copy depth? Camera depth texture. So yeah, okay. We create the depth texture here. Fuck yeah, that's true. We need the depth texture, and if we want a depth texture, opaque objects are gonna be included. We could probably play around with these values, get it to work. anyway. It's just that I'm really not a fan of a grid like this. Hmm. I mean, we have the outline data texture. We could use that one, so we get rid of all outlined objects. That's pretty good. Right now, we don't have any non-outlined objects that I care about that much, I don't think. Yeah, maybe we should just remove remove outlines on outlined objects, or remove grid on outlined objects, and then in the future we can see if we need to remove it on other stuff as well. We probably want the grid to be quite, or the terraform visualizer to be quite, it needs to know a lot about the environment and stuff like that. We need to visualize when it's possible to terraform, when it's not possible. Like, you know, mark it as red. That should be, maybe that should be the, up to the CPU. Or you could, like, the only reason that it's not looking that good here is because of, or I would say, we don't really have a grid in the Z direction. If it would look better. While UV, we take 2 here. Want to try how it looks if we exclude outlines. So what do we have? Util. We don't name the outlines HLSL. Is that the one? I think it is. We just use blit texture here. Okay. That's pretty good, actually. Outlines data render path. Here we do outlines data texture. We write to it and we read from it, and then we release it. So that's nice. Can we use this one then? Yeah, we could use this channel, but I want to remove data from this texture. I don't want to add data. The fuck. So if we do outline data center. We could do outlines, get outline data. Mm, 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 mm. Something like that. And then we multiply with this one as well. We do here, we go up. Yeah. It's quite a lot better, I think. But then I'm wondering, like, if we were to have stones here that are not outlined, we would be getting outlines on those. Maybe that's not too bad. Okay, what I'm wondering now is, do we have enough data to, in the shader, to, so I don't want to mark, I want to mark pixel values or squares that are entirely inside the radius. Not data points that are partly covered. So this one, for instance, it's less than half of this one is covered. So I don't want to mark this one at all. This one is fully inside, so we want to mark that one. So that would leave us, I don't know, like I want jagged edges on this one. Jagged. Can I just take a screenshot and show? Paint it. So if we have something looks like this right now, I would like this one to look maybe something like this, i.e. keep. In this case, maybe we should One sec, phone call. Be right back. Okay, back. Sorry about that. So, can we do this in the shader in some way? Probably. So if we take a pixel, let's see. This pixel, for instance, it's inside of the sphere. So originally, it gets rendered as a white pixel. It's part of the grid, but we want to exclude this one. And then if we take a look at this pixel, it's outside of the sphere. It's not included, even though it's part of the grid. Making so we're gonna have to add some extra scale to the shader, because there's no way to take this point that is outside of the sphere, outside of the object we're actually rendering, and adding it without making the object bigger. Pretty much. And then it's a question of, so basically what it comes down to is we want to truncate, we want to take the pixel position, we want to truncate it to center of each grid element. Then we want to check this value, I would say. So we have a position in world space, we truncate it to the middle of the data point. If the data point is included, then we continue onwards. Or rather, then we just continue it with it as previously. I'm just going to ignore the fact that, so initially, yeah, the truncation, we're going to focus on the truncation first. Which makes me wonder. We're always going to truncate to the closest center point. That's good. I think it should be pretty straightforward. I wonder, what I'm a little bit afraid of is, Yeah, we might get a case where, so in this one, the edges that are located between one pixel that is included and one that is not, it might be thinner than the ones inside here. Because if we take a look at this pixel right here, will be truncated to this position. It will be included, so we draw it as white. This pixel right here will be truncated to this one. It's within, so we draw it. But if we do the same with this edge, we have on one side we're inside, on the other one we're not. So we get like a half a line here, I reckon. And that's not... That won't look good at all. We have any way around that? Yes, we could add a... We could probably add some sort of error margin, maybe. I don't know. We can solve it in some way, I think. Not entirely sure of how, though. Let's see if we can truncate the positions to the center of pixels. Let's see. Um, bu- 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 First of all, I want to do float to world UV. I'm going to call it grid UV is equal to world UV plus the offset. So we're going to keep the original world UV around. Oops. Wonder if we need... Because I know that this one is actually centered at the center of pixels or data points. So I wonder if we can use this one. So we want to truncate this one and not this one. But that's not entirely true. No. It's the offsetted one we want to truncate. So we want to truncate it much like we do in from brush visualizers, something like this. It's a simple occasion. So we want to do round world uv.x divided by our delta, which in this case is, what is it? 1 divided by 1.0 divided by grid size.x, I think. And I want to multiply it with 0 divided by the size of the x. We can probably take this one and save it as a value somewhere because we're using it a lot. This division right here. Pretty much use it here. 2. We use it here and here. Oh well. Let's see if it works, first of all. I just want to try this. We're gonna do if distance between world truncated UV and world UV, this one is less than 0.1, and 1, 0. Mm-hmm. 0. Should be okay. Have grid size here. Still. Grid size 512. Hey, that's better. Didn't know we were working with such small values. See, it's the center. I think this is roughly what we want. So then if we check is within sphere, so is within sphere, instead of checking distance to sphere like this, we're gonna do or instead of taking distance between position in world space and sphere center, take fuck, is it position in world space we want to truncate? We don't want Y. Probably want to do have to be careful here. Sphere center is in world space, so we need to transform it to this UV space if we want to compare it. So we can't just take this one and put it in here. Y. Have to be careful with the Y dimension as well. Do we? Makes me wonder if we want to take position world space and truncate that instead of world UV. And then just compare X and Z, maybe. And instead of 1 here, we go with bounce extent 2. By grid size X. I think we're gonna double check this one as well. Then I want to test return or if distance between position world space, position world space And grid size doesn't have Z, it has Y. Okay, that's pretty fucking great, I think. So pretty much what we're seeing here is what I would like to see. But with the grid line highlights. So position truncated is within sphere. So what we want to check here now is position world space. We want to replace this one with position truncated world space. Maybe. Somewhat. It's not perfect. So we can see that here it works somewhat. Same here. Like this. Here we originally we would have lines here as well. Now we don't. So we get something like this. This I like. But we can also see here the problem I mentioned before. So here we get half lines. So this line right here has half the width of this one. Okay. Okay, and the reason we see these lines here is probably because this one is within. But then the object itself is smaller here. So we could do... We have a nice little test variable here we can try some things with. Sphere radius, we're gonna subtract test Z from this one. Which is 0 by default. And if I make it bigger... Here we get something. This is more what I want to see. That looks pretty damn great, I think. Except for the thinner outer edges then, of course. What did we have? 0.0... No. Ah, fuck it. Let's try. I want to see how it looks when we actually have the... When we have the correct terrain in place. We do... Test... I don't know what I put here. 0.1... Let's go 2. And the thinner edges. I think we have some problem with... We don't take Y into account. Definitely want to take Y into account as well. How do I want to solve the thin edges? First of all, we're gonna line with, there we go. Ooh, we actually have this here, yep. I wonder if this case is because of the Y comparisons we do, which we can't really do. It's fucked. Mm. This right here. What is going on here? Get it here as well. Hmm. Wonder if it's Y. If we do a distance comparison on only X and Z, only X and Z. Be sure that's what we want to do. So I'm talking about, we do X and Z here, and we remove Y from here. That looks better. We can also do some nice interpolation. Some nice interpolation which means that we fade in the new. So like squares at the edges, we fade them in, so we don't get this flickering when we move. So when new squares are being highlighted, we pretty much just pop them in. We can probably fade them in some nice way as well. But what I worry about is how can we possibly solve these? Like half. have selected squares pretty much. Yeah. We could possibly... So we want to include this pixel. We don't want to include this one. We could possibly... Yeah, I think before we truncate them, we take the position and we move it a tiny bit towards the center, which means that this one, move this one towards the center, which means that it will truncate to this one, which is included. This one, we move it towards the center, it will still truncate to this one, it's not included. Points here will truncate to here. That could possibly work. Let's try it. We want to move towards center with an absolute value. I'm wondering if we probably want to move towards the center related to grid line width. But maybe we can do float 3 position set dead world space is equal to I think we might as well position BS plus and then we try and calculate direction, which should be normalize what is it? Position VS minus sphere center XYZ. That's our direction, and then we multiply it with a length, and I'm gonna try and do, actually we're gonna do test.w here. Something like that. And then we take this one here instead. If we this one, I didn't think about these, but that's true. If we take this one negative, we want to go positive, so the other way around here, I think. And then we do 0.032. It sucks that we get these as well. But 4, 3, 2. That's good. There should be a value on W here that is like mathematically correct. 0.02 looks good, but I have no idea why. Line width is 0.13. 0.13, that's line width, but at every point we actually have 2 lines. So we divide it by 2, and then half that is 0.0325. 325. But if we go this wide, we actually get some artifacts here, which I don't want. Um, 0.13. 0.5. 5. 0.01625. 0.1625. That's a little bit too small, or is it? We get some artifacts there. Three, 2. Yeah, one thing with this as well, with this solution, is that we don't get the free anti-aliasing here. Which is unfortunate. I don't know if it's probably not that important. Yeah, so the line width doesn't have anything to do with it. That's good to know. So what I want to check then is offset we want to move. Is it 100 divided by 512? 0.1 divided by 512. So 0.0019. 2, 3, 4, 5, 6, 7. Yeah, we get this. So a little bit of highlight here. Maybe that's not too bad. Oh, this one is rough as well. But is this one height related? I wonder if we wanna, when we move this one, float 2, float 3, position VS, and we just use XZ. Then we don't get any half squares. That's good. I think this looks pretty good, but I just know that I'm gonna hate, like, knowing about these artifacts. If you know about them, you will definitely see them. You see it here as well. This one as well. So maybe this isn't the best way to solve it. What is? But is it that bad? Oh, what's happening here? What's happening here? Okay, here we don't see. Okay, I get it, I get it. The Y still affects it. It's pretty rough. When we're about here, we want to make this one small. Or bigger, I mean. Okay. But, so if, let's see here, we have a few issues still needs to be solved. I want to explore some other solutions for this, because I don't think this one cut. Yeah, not that big of a fan of this one. And then I also wonder about the Y. So when we work with this grid, we don't want to take Y into account at all. I thought we had removed most of that issue, but we haven't. Let's see. So here, distance to sphere. Do we still use this one? No, we don't. Position VS. Position truncated is within sphere. Pretty much don't use it here. So where do we get that issue from? Oh, I might know. Yeah. I think we do it the correct way in the shader, but it's an issue with the sphere we're actually rendering. So if the sphere is high up, we get something like this. We truncate to this position, it's actually within the sphere, so we should be drawing this. But But I mean, this is probably just an issue because we're not working with the correct data right now. So our data where we actually put the sphere, we have a mismatch since we recompile the shaders. We don't get the data, the correct data. So I'm wondering if this is a non-issue. 0.007. Probably is. So by default, we render half squares. But if we move this one and then we add 0.007. We could still see this issue. Depends on what level of changes in the ground we actually want to. Maybe a circle isn't the best object to render this one is, or a sphere that is. Maybe we should just go with a box, honestly. Box. EP. Thinking here. Box is probably better. With the current visuals, the don't get the anti-aliasing here, which sucks. And if we go, 1 sec. Ooh. What do we need to do to get these right here? XZ, XZ, sphere center. XZ, XZ, XZ. XZ, XZ. This is extremely weird. I'm wondering why we're getting this here. We don't truncate to the correct position for some reason. So this one right here. Yeah, so for these pixels, we move them towards the center. Yeah, this is a fucked up way to do it. Oof. So for this pixel here, we offset it towards the center. It's aligned with the center on the Z-axis. We don't really get closer, so it still truncates to this. We lose this one, but we get these artifacts. Okay. So yeah. We can't dissolution. We can't use dissolution at all. It's good to know. So it's not only that little artifact I was annoyed by. What can we do instead? So it's pretty much like the edge points here. We want them to truncate inwards, or we want them to truncate towards. We do something smart here. If the point is, I was thinking if the point itself is within the sphere, but the truncated point it truncates to is outside, that won't fix this one. Hmm. Still see that we have is this. Is that? Huh. Definitely want to solve that as well. But that might have to do with how we render the terrain. We're gonna look at that one later on. Can we truncate in? I mean, we could truncate in. If we we could try and move it away from. If we have this point, we calculate its truncation point. And then we move away from that truncation point, and then we truncate it again. How would that work for this point right here? Truncate to this one, we move away, and then we truncate to this point. This, oh, maybe. Wonder. Maybe we can try that. This right here truncates to this one. We move it away, truncates to this one. But I want. Maybe. How would that look? World truncated UV. But this one we don't use. Care about this one. Position truncated world space. We do this. Do B. E. It's even worse, but Are we moving in the wrong? And that feels weird. We truncate it. Check the direction, much, or calculate the direction. E. Hmm. How long have I had that issue? Why do we get these here? That's what I'm wondering. This point right here, it truncates to this point. We move it away. Oh, we actually don't move it away, we move it closer. I want to know this. But then we get this. Uh, hmm. Yeah. We get the inverted problems for points that are, this one truncates to this one and we move it away from this one, and then when we do the second truncation it's outside. We could solve that by checking if it's inside previously, but that doesn't really solve this issue. I'm wondering what happens with these. Sweet. Here we get the outside but not the insides. Here we get the insides but not the outsides. So if we would do PT, load 2, load 2. Let's remove this one. Said we calculate PT and then we do this, then we do this. PT, So we only do this one if this one is outside. I don't know. Is within sphere. If I don't know. The only problem we get now, I think we get pretty good. How does the anti-aliasing look? Yeah, we get pretty good anti-aliasing, except for at corners. So this one truncates to this one, it's outside. We move it the other direction, which should be, which is out here, and then it truncates to this one, so we don't get it. I guess that's what's happening. Something weird is happening there as well. Yeah, we get that point. Hmm. Hmm. Has to be a nicer way to solve this. You can always check. Truncate in 4 directions. Feels like too many calculations. else we can do? Another approach, a different approach. We should be able to, yeah, we have some points here that are way too messy, I reckon. So we have points we would like to draw that are that pretty much belong to the two closest grid centers are both outside. And then when I think about it, we're gonna have to handle the aliasing here ourselves. These edges will suck. Or actually, I wonder if we can calculate two of these. And one that has a radius that is one bigger. And then we check if both of them is being rendered. Does that make sense? Yeah, if both of them are being rendered. That's it. That work? We do this. We do this. No, 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 no. Or we could, if we have something that lies right at the edge, then we make this one a bit larger, I suppose. Or smaller for the other ones. Maybe. That means that, okay, we have a distance here. If we just do is within sphere, distance PT sphere center. So I'm wondering if we can make this one. Either we could do thinner in here if we're within the sphere with a margin, or we make it thicker here. I think the second option, maybe we could get some anti-aliasing here as well then. Oops, sorry about that. That just means that we can't throw away the pixel too early. I'm a little bit annoyed that scaling solution didn't work. So moving towards the center. It's a annoying problem. An annoying problem is like this pixel here. We have to make it understand that if this square here is not of interest, then it should default to this one. Like then this edge should belong to this one. At most a pixel belongs to 4. We could check all of those, render the point. Maybe we could do some aliasing there then as well. So if we have this point, it has one of its truncated points is inside. Yeah, fuck, is that how we're gonna have to do it? Take the position, truncate it 4 times. Da, da, da. And then we calculate an alpha value based on how many of these 4 points are within. This one right here, it's always just 2, I reckon, or 4 at most. This one right here, for instance, gets this, 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 and this. 2 of them are within, so we have 0.5 alpha. We're gonna have to calculate an error as well. But what would happen with this point, for instance? This one right here. Truncate it, 2 is inside, 2 is outside. We render it and we're screwed pretty much. Yeah, that's not good. Probably the best solution would be to play around with the, so base the, no matter which solution I go through in my head of these, we're still gonna have the issue of or we're gonna have the issue of aliased edges, unless I don't want to go in and change this method, but we could also play around with this one, honestly. Oh, so this pixel right here, if it's inside, it might be inside on x-axis but outside on y-axis. And we do one, maybe. Actually, we get line width is currently tied to grid size. So if we play around with grid size, we're going to get greater lines like this. That's not good at all. Bounds, same. Yeah, what's up, Diligence? Are you doing terraforming? Yeah, pretty much. Or we're refining the terraform system. And I wanted to give this terraform marker a glow up, pretty much. I wasn't really happy with how it previously looked. I want more of a pixel pattern. So that's what we're doing right now, generally speaking. Specifically speaking, I want to fix this. So pretty much the default, I want to draw a grid and we do it like this, but I don't want to have half lines like this. I want to have you show, so for all the active data points or squares, you render the full edges of them, so no half edges. The only problem we have here then is that our outer edges are always going to be like half edges, you know? It's not that, it's pretty apparent. I want it a little bit more refined than this. I mean, it's okay. But if you really, really look at it, you can see here that you have half edges at the end. So I'm just exploring different ways of reducing this or fixing this. Still looks good, but nothing less than perfection. I mean, yeah, like I haven't. I thought I could at least give it a few hours, this problem. It's not a 20-hour problem, but definitely 8, 10. If we can't solve it by then, we might move on. So if we take a look at the point, which we render here, so this point, for instance, this point has every point has 2 centers, right? We don't have a point that has 4. I wonder if or can a pixel have, yeah, I guess it can. Yeah, I think we can do something with this, actually. I think we can do some nice, we truncate to all the closest neighbors, and then we do, so each point has 4 truncation points, and then we do some nice bilinear filtering between them. But I'm still questioning. Yeah, that could work. That could work. Yeah, I have to run, but I'm gonna solve this tomorrow, or we're gonna give it tomorrow as well, and then we move on. Because yeah, this is acceptable, right? It might even be less apparent when we have the proper, when we don't have the contrast between pure black and pure white. But we're gonna look into it a bit more tomorrow. Hopefully we can solve it. It was a nice, it was a nice stream given the fact that I haven't been streaming for more than a week. So I'm okay with this. This is a first stream. Diligence, you too. Thank you so much for watching, everybody. Appreciate it. Hopefully I will see you tomorrow. Have a great rest of the day. Peace.